This is your video for Investigation 1.3 from the book Shapes and Designs, where we are going to be looking at estimating measure rotations and angles. This particular video, there are two learning targets. The first one is to use angle notation properly, and the second one is to estimate within reason, so something within like 20 degrees of what that angle measure would be without using a protractor or any type of compass that would tell you what the angle measure is. So let's look at notation first of all. And this also ties in to our vocabulary. If you look at the angle, you have your three letters, and it is actually made up of what we call two rays. So in green, that is one ray, or kind of one part of the angle. And in pink, that is the other ray. And you can see right here in the middle, where it actually turned black, where the two colors meet, that is the vertex, or the point that they share. So to properly notate the rays, or the two rays that create this angle, we always start from that midpoint, or the point that they share, or that vertex. So we have a ray called BA, and then we have another ray that's called ray BC. Now in math, to be able to tell whoever is looking at our work that we're not just talking about B times A or B times C as two variables squished next to each other, we use the notation with the line and the arrow above it. And that arrow always points to the right. And now we are notating that we are talking about a ray. So ray BA and ray BC. Let me go ahead and get rid of what we've got on there and start with clean slate. Alright, angles. Now with angles, you always want to look at them in a counterclockwise turn. So counterclockwise would be going in that direction. If you think about a clock, it's going opposite of the hands. So from ray BC, I drew my arrow in the counterclockwise direction. What that means then is I have to name my angle starting with C up here, and then I move following that counterclockwise rotation. So I have angle CBA, because I'm going kind of opposite of what you would expect, because it's that counterclockwise rotation. Now, that counterclockwise rotation can continue, and it can continue kind of below that angle. So now I have created another angle, and that angle is called ABC. So even though I only have those 3 points, I am creating two separate angles. I'm creating the one up there in yellow, and then I'm creating this one here in red. So kind of think about it as a top angle and a bottom angle. Now angles also have a proper notation, and it looks very similar to a less than sign, but it's a little straighter, where I have angle CBA and angle ABC. So that less than sign is a little bit more kind of like a sideways V, but an angle, you've got that flat part, and then it's a little straighter up. But that is, now I don't have to write out the word angle. I can just use that notation. So always measure angles in a clockwise rotation. So using that, we're going to look at these 4 examples, and you can see that these already have the pink arrows that are showing that clockwise rotation. So here you've got the clockwise rotation, and again that clockwise rotation. So there's going to be 2 angles that we have to list, and we're going to estimate the rotation, and we're going to make sure that we use proper notation. So for the first one, the first angle, so we're going to use proper notation, so I'm going to have angle, and we're going to start, I'll actually switch colors here, it might be a little easier to see. We're going to start on this ray, and we're going to move that way. So I'm going to have angle A, V, B. And if you need to, turn your paper to do an estimation. What I see is that this is wider than a 90-degree angle, but if I were to draw in some extra lines and I were to make it straight, that would be 180. And if I were to think about a 90-degree angle, a 90-degree, I remember, makes that nice, perfect square corner. So I'm a little bit bigger than 90. Maybe an estimation would be something like 110 degrees. And maybe you think it's 100 degrees or 115. Remember, we're looking to be within like 10 to 20 degrees, and you should be able to argue as far as why you picked the amount that you did. My argument would be, well, 110, I know it's got to be bigger than 90, but it has to be less than 180 because it's not quite a straight angle. Alright, let's get rid of all that notation so we can see. Oops, and I think I erased my angle sign there. So the next angle that I have, remember, now we're starting here on this ray, would be angle BVA. And so I'm following this. And if you think about this being, again, let me actually switch colors here. If I go back and draw in that line, which would be a straight angle, I'm going beyond that 180. If I start here, that would be 180, but I'm going past it. So maybe this would be 190 to 195, or you might even say a 200 degrees. So you want to use your knowledge of your acute, your obtuse, your right, your straight. Those are all benchmarks that you are able to use. Alright, what I would like you to do is pause the video and do an estimation for the 2 angles for 2, 3, and 4. And then when you're done, come back, play the video, and see if your estimation is somewhat close to my estimation. Alright, so check your answers, see how you guys did. Again, you don't have to have the exact numbers I did. You're looking to see if you are a fairly close estimate. One thing that I did not mention, but is a good thing to notice, is that we know that a full circle has a rotation of 360 degrees. So if you look at these and I'm looking at number 3. And if you look at those two angles, they make a full circle, or a rotation of 360. So I came to that realization by the time I got to number 3. So my two angles add up to 360. So I estimated the size of the little one, and then I subtracted that from 360. I used that same idea as a full circle for number 4. I estimated the little one at 80 and then subtracted that from 360, so I got the size of my bigger one at 280. Again, you're looking to be within somewhat of a close answer of me. This is an estimation, so I'm not looking for an exact. We will do that later on when we use compasses and protractors. If you have any questions, make sure you make a note of them, write them down, and connect with me and your learning group in class.